So as we know in yesterday's class, I taught you what is electronic configuration. So can anybody tell me simple, what do you mean by electronic configuration? So just I will say electronic configuration. Also we can call it as electronic arrangement also. So let it be electronic arrangement or electronic configuration. What do you mean by that? I want the response from. What is what? Yes, please. Is the distribution of electrons in different cells or energy levels in order of increasing energy. Is right or wrong? All of you? The distribution of electrons in an atom, that is only we used to call it as electronic configuration. Distribution of electrons in different cells. So we are having a different cells given by Mr. Bose. What is the cells names? Anybody? K cell, L cell, M cell. So in these cells, how these electrons are distributed, that is only we can say electronic configuration or electronic arrangement. And these electrons are arranged based upon the increasing energy. So if we'll arrange all the cells in the increasing energy manner, so which cell is having highest energy? Everybody? K cell, L cell, M cell and N cell. Who is having a highest energy? N cell. And always remember the shell which is closer to the nucleus having low energy or high energy. Yes, please. Having the low energy. The shell which is having closer to the nucleus is always having the low energy, and the shell which is having which is present far away from the nucleus is having more energy. And we know also we have done yesterday. So how many electrons are arranged? The number of electrons, the maximum number of electrons present in a given cell, we can find by using one formula. What is that formula? Maximum electrons in a given cell. Which is the formula? All of you. Given 2 into n. So we have done. So n is equals to 1. K shell. K, L, M and N. So n is equals to 2, n is equals to 3, n is equals to 4. So what is the electrons? Can anybody tell me? K is equals K shell. Maximum how many electrons we can? 2 electrons. L cell maximum how many? 8. And M cell 18. And N cell how many? 32. Okay. So that is what we can say. So 2 into 1 square, 2 into 2 square, 2 into 3 square, 2 into 4 square. So if you will solve that, you will get 2, 8, 18, 32. So like this, the electrons are arranged. This is what we can use a formula to find maximum number of electrons we can fit in a given cell. Now, whatever the cell, if it is the last, it may be a K shell or maybe a L shell or maybe a M shell or maybe a N shell. So that last shell we used to call something. What we used to call, guys? Here only K and L. Here K, L, M. Here K, L, M and N. So last shell. What is the last shell we used to call? Everybody? Valence shell. So the last shell, or we can say valence shell. So there only the reaction will take place. Means electrons will transfer, or electrons will receive, or electrons will share. Only it will happen at valence shell. So if you take any valence shell other than K, so in K maximum how many electrons we can fill, guys? All of you. K only maximum we can fill how many electrons? Maximum 2 electrons. Understanding? Even though if it is a valence cell. If it is a valence cell or if it is a normal, only we can fill 2. So other than this, if you take any cell is a valence cell, irrespective of their capacity, maximum we can fill how many electrons? All of you. Yes, please. 8. Yeah, if it is L or M or N, understanding, or valence cells. valence cells, then maximum we can fill how many electrons, guys, in valence cell? Maximum 8 electrons we can fill in valence cell, even though their capacity is more. Do you understanding? Suppose if you take M cell is the valence cell here. What is the capacity of M cell? All of you. What is the original capacity? All of you.
18.
Yeah, original capacity is 18. But if M is valence cell, then we can fill a maximum how many? Only we can fill how many? 8 electrons. Understand? That is you should understanding. So even though their capacity is different, we people can arrange only 8 electrons if the given cell is the valence cell. Understand, Mr. Gokul, Danishkar? That is what you have to remember it. Harish, who is missing, absent? Omar is absent. Next, still people need to join. Yeah. Understand, everybody? So irrespective of their capacity, if it is the valence cell, we can fill maximum how many electrons, guys? We can fill maximum 8 electrons. That is what you have to remember. So this is what we studied in the last class. So now from here we'll continue. As I told you, now today we'll see what is the importance of this electronic configuration. That is what we can say significance of electronic configuration. Please write. Significance of electronic configuration. So why we should know electronic configuration? Because electronic configuration will give lot of information about the atom. So let us discuss what is that information, how to use this for our analyzing the properties of atom. That is all we'll discuss now. Okay. So please make it, everybody. Shall we start? Good morning, Ashwin. Omar is not there. Who else is missing, Harish? Nimish is not there. Nimish is there. Okay. Right. So you can see here the significance of electronic configuration. The first thing, based upon the electronic configuration, we people will come to know the size of the atom. So that is what you should understand first. So to know the size of atom. Okay. Anyone having doubt, kindly ask me immediately so that nowhere you should feel difficulty. So very slowly only will go. Anything doubt, kindly ask me. Now, for example, I will give you one atom having only one shell. I will give you another atom having only two shells. I will give you another atom having three cells. Now, tell me which atom is bigger? All of you?
Lost.
Last one. Because here, how many cells are there? Here number of cells is how many? 3. Here number of cells is what? 2. Here number of cells is 1. So based upon the number of cells, can you able to identify the size of the atom? Yes or no, Mr. Danishkar? Arun? Kaushik? So that is what it is. So by using the electronic configuration, we people can say size of the atom. Write it. By knowing the electronic configuration, we can know the size of the atom. More number of cells, more the number of cells. Mr. Johan, take notes properly, everything. I want to see everything. That is, larger will be the size of the atom. That is what you have to remember. Clear, everybody? Yeah. Okay, Harish. Please make it, everyone. Understand first point, everybody? That is next. Second one, to locate the position of the element. To locate the position of the element. To locate the position of element. So what is this position? Let us explain so that you will understand very clearly. Now, so you might be knows periodic table. You might be not seen, but definitely you might be seen our school or somewhere. The periodic table will be like this. Have you noticed like this a periodic table? All of you? Yes, please. Here one element will
Yes,
be. Yes. So this is what we will say periodic table. So actually, this is a periodic table is the table which will give you the idea of arrangement of atoms, how the atoms are, how the elements are arranged in a row wise and as well as column wise. That is what we will say actually is a periodic table. So it will be having totally, all of you remember, 18 groups, okay, and 7 periods. 7 rows actually we will say. So that is what seven periods and 18 groups it will be having. So that is what we will say periodic table. Now with the help of electronic configuration, we will come to know where this element is present. Either it is present at left side or present at the right side or present at middle. So this all the information you people will come to know when we come to know the electronic configuration. Do you understand everyone? Abhirami? So to locate the position of the element in periodic table, what is this table we used to call, all of you? Periodic table. What do you mean by table? Periodic table? Arrangement of elements. Proper arrangement of elements. Understanding? Based on their properties. Based on properties. The properties means what, Mitakshri? Maybe physical properties as well as what properties? As well as chemical properties, both. That is what we used to call as periodic table. All of you should remember that. So, with the help of electronic configuration, I can say where is this position? It is present at left side or right side. Where it is present, I can say that. So, with the help of electronic current. Suppose the number of cells represents the periodic number and the valence electrons will decide the group number. That is you have to remember. Okay. For example, if I'll say the number of cells decides, okay, or represents the period number. Okay. Period number. I'll say that. And valence electrons. Valence electrons means what? Anybody can tell me? Valence electrons. Valence electrons means what? Anybody? Total number of electrons. Number of electrons present in where? Number of electrons present in where, guys? Present in
last cell.
Yeah, last cell or valence cell. Please note down. Last cell or valence cell is called valence electrons. So remember, the number of cells will decide the period number and valence electrons will decide the group number. Okay, everybody? So now, as I told you, totally how many groups are there, everybody? Yes, please. 18 groups and 7 periods. That is what periodic table. Understanding? So now, with the help of number of shells, I can say which period it will come. Valence electrons, I can say it will come in which group. Okay. Shall we discuss now, everybody? Now, let us take, for example, if element having, example, if a given element has 1 or 2 electrons. How many electrons? 1 or 2 electrons. Understand, Amma? In its valence cell. In its valence cell. Understand, Harish? Then, okay, it will come in first or second group. That's all. second group. So what is the first and second group? Where it will come? Left side or right side? Everybody remember 1, 2, like that 3, you will come 14, 15, 16, 17, and last you will get what? Last you will get what? 18. Okay. So that is you have to remember from the 13. 3 to 12, 13 also will come. So 13 and 3 to 12, like this it will go. 12 here will come. 3, 4, 5, 6, 7, 8, like this will come here. So this is what. So if the valence cell having 1 or 2 electrons, then it will come in which group, guys? Either group 1 or group 2. That is what you have to remember. Means it will come here. Here it will come. Is it okay? Tejaswini, understand? Shruti? If valence electrons are 1 or 2, then it will come. If it is 1, group 1 will come. If it is 2, it will come in group 2. Okay. Now, for example, if I take next, suppose valence electrons are 6. Valence electrons are 6. Then it will come in group 16. All of you remember that. If valence electrons are 6, it will come in where, guys? All of you? Group 16. If valence electrons are 7, it will come at group 17. If valence electrons are 8, anybody tell me 8 means what gases? I already told you. 8 means what gases? They are noble gases. Understanding? Noble gases, or we can say unreactive gas. Unreactive gases. So they will come at which column? Anybody can tell me?
Group 18.
Group 18. That is what you have to remember. So based upon the valence electrons, can I say, am I told you or not? It will come in which group? Can we say it or not? Yes, please. Yes, all of you. Next, same way, number of cells. Number of cells will decide which period. Period will decide. Now let us take all of you. Sodium atom. What is the sodium atom atomic number? I told you to read. What is symbol of sodium? Anybody tell me? Symbol of sodium. Na. Correct or not? Na. Now what is atomic number of sodium? You all studied, correct? Let me know. Atomic number of sodium. What is atomic number of sodium?
11.
11. Then what you studied yesterday? What, Harish? Nothing studied. Now write the electronic configuration of sodium. Let us see. So first cell. First cell, how many can fill? K shell. K shell, how many? K shell, how many electrons can fill, guys? Maximum.
2 electrons.
2 electrons. Next, L. L cell maximum, how many can fill? 2 into 2. 8 electrons. So 8. So 11 minus 2, 9. 9 minus 8, 1. So last cell, K, L, M. M shell we can fill 18. But how many we have? We have only how many?
1.
Only 1. So total number of cells are how many? Verified. K, L, M. Total number of cells. How many, guys? K, L, M. Totally how many?
11.
The total is cells I am asking. Totally how many cells?
Yes, sir.
3 cells. So there are totally 3 cells. So it lies in third period. Where it will lies? It will lies in which period, guys?
Third
period. And what is the valence electrons? What is the valence electrons? Last cell electrons. 1. So you lie in which period? Which group?
Third.
Group 1. Group 1, third period. Once again, I'm saying sodium, if you have taken, its electrons are 11. So arrangement K, L, M. 3 cells will come. 2, 8, 1. So what is the valence cell? Valence cell is what here? Everybody tell me. What is the valence cell? M is cell. How many electrons are there?
1.
So that it will come in group 1. Group 1. Now, how many cells are there? Number of cells.
3 cells.
Number of cells are 3. So that which period it will come? Period.
Third period.
Okay, now that is what it is. So like that, if you know electronic configuration, number of cells will give you the period. Valence electrons will give you the group. That is what you have to understand. Are you clear, everybody? Shruti, Tejaswini?
Yes, sir.
Yes, that is what you have to remember it. Please make it. All of you do it. Now, write the matter also. Now you can, I will show you that periodic table. All of you. So verify the sodium, where it is coming exactly, you can tell. So if you will see the sodium now, I will show you. You should tell me what is the sodium position. All of you should tell me. Group 1, period 3. Okay. So group 1, period 3. You can verify it. So all of you see here. Can you able to see here? Check it. I will show you. So this is the 1 minute. So you can see this is the period 1. This is the period 2. And this is the period 3. So which period it is coming? Sodium.
Third period.
Third period. This is the group 1. This is the group 1, group 2, group 3, group 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, which group it is coming? Yes, please. Group 1 and period? Period?
3, sir.
Period 3. That's all it is. Clear, everybody? So that if you know the electronic configuration, we can locate the position of the element. Is it okay, everybody? Others understood or not? Yes, please.
Yes, sir.
That is what. So totally how many periods? You can check it. 1, 2, 3, 4, 5, 6, 7. Don't consider these two. These two will come here only. Okay. That is, you will study in higher 10th class. But 10th class it is deleted now. I will only will teach you sometime. No issues. So totally how many periods? 7 periods. And how many groups? 18 groups. That is what you have to remember it. That is what periodic table we used to call as. Is it okay, guys? Yes, please.
Yes, sir.
That is. So please write it. Okay. So whatever you understand here, so please write it. Always remember, number of cells will give you which period it is, and valence electrons will give you which group it is. So till here, all of you finish it. Just 1 minute, I'll be back. Let us take one more example. So you all people will be convenient. Magnesium. Can anybody tell me what is the magnesium atomic number? All of you?
12, sir.
Yes, please.
12, sir.
Mg. What is atomic number?
12.
12.
12, sir.
Okay. So let us arrange the electrons first. So we all knows that magnesium is 12. Okay. And atomic number is 12. What is the mass number? Mass number 24. Mass number 24. So let us make electronic configuration. First, K shell. K shell, how many electrons? 2. K, L shell. L shell, how many electrons? Fastly. 8 electrons. Clear? L shell, it will be 8 electrons. And now make it 12 minus 2, 10. 10 minus 8, 2 is remaining. So what is the next one? Yes, please.
M shell.
M shell, how many? 2.
Sir.
That is. Now, so what is the number of cells? Number of cells.
3, sir.
Number of cells is 3. So which period it will come? Which period?
Third
Period, sir.
Third period 3 will come. Next. Valence electrons. Valence electrons, how many? 2. So that it will come in which one?
Second period.
Okay. So verify period group 2. Now I will show you that. Is right or wrong? You all should see that and tell me. So magnesium. So where it is coming, magnesium, check it. All of you. See here. Which group first? Which group it should come? Sorry, period. Which period it should come?
Third period.
So, this came or not? Third period. Next, which group it should come? Which group?
Second.
Group 2. Okay, group 2. Came or not? Verified. Clear? Gokul? Akilan? That is what you have to remember. So like that, whenever you know the electronic configuration, we can identify position of the element, which group it is coming, which period it is coming. Is it okay, guys? Aswin, Shruti, that is what you have to remember. So please make it. Do it fast now. Anything doubt, you can ask me. Clear? Sanjay? Next. Example you can take. Third one. Metallic or non-metallic nature. You can make it. Metallic or non-metallic nature. Metallic or non-metallic. And one more thing I forgot to tell you. Remember, if valence electrons is 1, then it will come in which group, guys? Group 1. If valence electrons are 2, then it will come in which group, guys? Group 2. If valence electrons are 3, please add plus 10. From here to plus 10, then it will come in which group? All of you. Group 13. So then what about 3 to 12 group? 3 to 12 groups, it is variable valency. We will study that. Variable valency it is. That is why they are called as transition metals. What is to call? Who is to call as? Transition metals. So if valency is 3, you have to say group 13. If valency is 4, anybody? Plus 10, where it will come? Group 14. If valency is 5, valency is 6, valency is 7, valency is 0. Okay, valence not, valence electrons, or you can take 8. Valence electrons. Valence electrons. Valence electrons 5. 5 plus 10, how much? Group 15. Next 10, group 16. Next 10, group 17. Next 10, group 18. Is it okay, everybody? Yes, please. All of you? Tejaswini, anything doubt, ask me. So, if an element has more than 2 electrons, all of you remember, if an element has more than 2 electrons in their valence shell, then its group number can be found out by adding how much, guys? By adding
10.
10 to its valence electrons. Is it okay, Mitakshri?
Yes, sir.
That is what you have to remember. So please make it. That point you have to remember. Clear? So that is what the importance. Okay. Next. Third point. Metallic or non-metallic nature. So we all knows that. You might be studied in chemistry second chapter. Elements can be classified into, of course, even 3. But basically, elements are classified into 2. In between, some other thing will come. Anybody can tell me? Elements are classified into what? All the elements. We can make it into what? We can make metals and non-metals. Of course, now third one is also there. That is what we will say what?
Metallic.
Okay. So forget about it. Of course, metallites are very less. Only 7 are there. Remaining all are okay, non-metals and metals only. So now we will identify either it is a metallic or non-metallic with the help of electronic configuration. So how it is? Let us see. Write it. Metallic or non-metallic nature. So we can identify easily if we know the electronic configuration. So we start now, everybody? All of you? Yes? Now. Can you say it? Yes or no? Please respond. Now,
Yes,
valence electrons, not valency. Valency we will study next. Valence electrons. I am talking about only what, guys? I am talking about only valence electrons. Understanding? So don't confuse about valency and valence electrons. Valence electrons means the number of electrons present in which? Outermost shell. Understanding? So that is what called as valence electrons. Valency is different and valence electrons is different. Be careful. Valence electrons. So valence electrons 1, 2, 3, 4, 5, 6, 7, and 8. Maximum how many electrons we can keep in valence cell? Everybody. Valence electrons, how many we can keep maximum? All of you.
8 electrons.
8 electrons. That is, we should remember. Clear? Now, here, if valence electrons are 1, 2, 3, then these all are called as metals. What they are called as? If valence electrons are either 1 or 2 or 3, then what they are called as? Everybody, they are called as
Metals.
metals. Clear? Now, if valence electrons are 5, 6, 7, they are called as non-metals. What is to call? Everybody, non-metals. Now, if valence electrons are 8, they are called as, what is to call? Everybody, noble gases. Okay, and including what? Helium. Okay, helium only 2, but even though it is also called as what gas? Everybody, noble gas only, because helium having only one shell. What is that shell, guys? Only one shell. Which shell it is?
A shell.
That is what it is. So that is why helium is also noble gas. Now, what about 4? 4 means they is to call. If 4 electrons are there, then they are called semi-metals or semiconductors, or we can say metalloids. So please write it. We'll say metalloids, or we will say semiconductors, or we can say semi-metal. Okay, everybody? Yes, please. All of you, but except, for example, carbon. If you have taken carbon, carbon is 2, 4, K and L. So carbon is non-metal. What is a carbon, Amma? All of you? Carbon is a what? Non-metal. Is it okay, everybody? Yes, please respond. Now,
Yes, sir.
take silicon, for example. How many of you know silicon? Silicon theriyuma. So symbol is Si. So its electronic configuration is 2, 8, 4. So 4 is there. So what is this called as? Metal or non-metal or metalloid? It is called
Metalloid.
as metalloid. Understanding? So that is what you have to remember. It is a metalloid, or we will say semiconductor. What is to call? Semiconductor. Understand, everybody? Yes, please. If it is
Yes, sir.
electrons are there, then what we is to call them? We is to call them as noble gases, or we will say inert element. We can say that. Okay. So this is what it is. So if you know the electronic configuration, we will know either it is a metal or non-metal or metalloid. Yes or no?